Hello, so today my group will be presenting about ice that burns, or in other words, methane hydrates. We will start off with the first topic, which is the chemical reactions or principles involved in the reactions of ice that burns. Ice that burns, or methane hydrates, is a crystallized solid structure with hydrogen bonds with water molecules. This creates a network of cavities where methane gases molecules stay in place. Methane hydrates are formed by the interaction between water and methane at low temperature, up to 25 degrees Celsius, and moderate to high pressure, which is equivalent to the depth of 300 to 500 meters underwater. During the process of formation, methane gas moves or migrates into cold or high-pressure sediment layers that contains water, where it becomes trapped inside the crystalline lattice structure, which is a symmetrical, three-dimensional structural arrangement of atoms. Methane hydrates can be found mainly in ocean sediments and permafrost regions such as in the Arctic.
Methane hydrate is CH4.NH2O. The principles involved in this reaction include, first of all, clathrate chemistry. The clathrate chemistry focuses on a compound of one type of molecule that forms like a cage-like structure and traps another molecule inside. In clathrate hydrates, the water molecules will form a hydrogen bond network with cavities that trap gas molecules like methane or carbon dioxide. Next, the combustion reactions. The combustion reactions are chemical processes where a fuel reacts with an oxidizer and produce heat and light, often as a flame. Methane hydrates can be combust in the presence of oxygen when it is being heated. This is because it releases methane gas where it is being heated. The next one, the phase changes. The combustion of methane hydrate often involves many phases transition, such as solid to gas, where hydrate dissociates into methane gas and water. Solid to liquid, when ice components melt into liquid water, and liquid to gas. And lastly, thermodynamics. Methane hydrates have both exothermic and endothermic reactions. During the formation of methane hydrate, it is classified as an exothermic process, which means it gives off heat, as the equation states that methane plus oxygen forms the carbon dioxide, water, and heat. In contrast, the methane hydrate is broken down into water and methane. It is the process of endothermic reactions, meaning it absorbs heat, as the equation states that methane plus water equals the methane hydrate. Boom.
Next is the link to the applications of methane hydrate. First, methane hydrates to produce hydrogen fuels. Methane hydrates can be decomposed to produce hydrogen fuel through various methods, such as dissociating methane hydrate into methane gas, converting via steam, methane reforming, and methane cracking reactions. And lastly, using plasma-assisted techniques to enhance decomposition and hydrogen use. The dissociation process of methane hydrates to create hydrogen fuel starts by breaking down the solid methane hydrate structures into methane gas and water, which can be written as CH4 plus NH2O, followed by chemical reactions that convert methanes to hydrogen. Due to its conditions, such as an increase in plasma energy input, are applied, these water cages disintegrate and release free methane gases and water vapor.
Methane hydrate can also be used as a primary energy source in the chemical sector, industrial energy, and power generation. Methane from hydrate can take the role of conventional fossil fuel in the industrial sector for high temperature processes like cement, steel, and glass making. This hydrogen is subsequently utilized in a variety of synthesis procedures to create a methanol or ammonia for fertilizers.
To talk about the benefit and risk of using methane hydrate. Methane hydrate is seen as a promising energy source for the future. Just 1 cubic meter of it can release up to 180 cubic meter of methane gas. Methane is a clean burning fuel that produces less carbon dioxide than coal, oil, or even alcohol-based fuel. However, using methane hydrate comes with serious risks. It falls deep under the sea. in soft, unstable sediment. Sinking it can change the pressure and temperature in those areas, which can harm marine life like squid and jellyfish. It may also cause underwater landslide or damage ecosystem. So currently there are no clear safety rules for handling methane hydrate, and the process is really expensive and difficult. So in summary, while methane hydrate has great potential as an energy source, careful research and responsible development are needed before it can be used widely. Thank you.
Methane hydrate are crystalline compound in which methane molecules are trapped within a lattice of water ice, stable under specific pressure and temperature conditions, typically found in deep marine sediment and permafrost region. Methane is a potent greenhouse gas with global warming approximately 20 times greater than carbon dioxide over a 100-year period. Its release into the atmosphere can significantly amplify global warming due to its strong radiative forcing capability. As global temperature rises, particularly in oceanic and permafrost environments, the stability of methane hydrate is increasingly compromised. This warming can trigger the dissociation of hydrate structure, leading to the release of methane gas. The subsequent increase in atmospheric methane concentration can further enhance the greenhouse effect, creating a positive feedback loop of warming and methane release. Methane hydrate exists in a metastable equilibrium, making them highly sensitive to environmental perturbations such as changes in temperature and hydrostatic pressure, which are often driven by fluctuation in sea level. Beyond atmospheric implication, methane release into the ocean can reduce dissolved oxygen concentration, potentially leading to hypoxic conditions that are detrimental to marine ecosystem. Furthermore, rapid dissociation of methane hydrate can destabilize submarine sediment, increasing the risk of subaqueous landslide. Such events may in turn generate tsunamis, posing geohazard risk to coastal communities.
Now, let's talking about effect on human. Methane hydrate can also affect people. The extra methane in the air can lead to more extreme weather like stronger storm, heat wave, and drought. It can also cause sea level to rise, which can flood cities near the coast. The amount of methane that is present in gas hydrate onshore and offshore is perhaps 3,000 times the amount in the present atmosphere, and instantaneous release of methane from this source could have an impact on atmospheric composition and thus on radiative property of the atmosphere that affect global climate. Some scientists and companies are interested in using methane hydrate as a new energy source. However, getting the methane out safely is difficult and could harm the environment. Now, this is the end of our presentation. If you have any question, feel free to ask. And thank you for listening. I hope you guys have a very good day. Bye bye!